In this video, we're going to go over how you should approach any factoring problem that you come across on a test, when working a homework problem, wherever. And so maybe you're asked just to factor an expression, or maybe it's a bigger problem where you're required to factor as you work that problem. And so this is the general approach that the textbook gives. And I like this outline. If I would have built an outline myself, this is exactly how I would have done it. All right, so you have an expression in front of you. It could have 2 terms, 3 terms, 4 terms, 5 terms. Now, before we go over this, I want to point this out. In real life, probably most expressions you come across won't be factorable. At least if you're considering factorable to mean you can separate it into factors that have just whole numbers in those factors. Yeah, if you want to factor something and have like x plus 0.23 times x minus 5.48, well, then you can factor most things. But we're talking about factoring where you end up with just whole numbers in your factors. In real life, most things aren't going to be factorable. But if you're in an algebra class, you're taking a test or you're working a homework, and you know that you're supposed to be factoring whatever's in front of you, either because that's what the question is asking or because you know that's the step you're on in a problem, then there's a 99.9% chance that one of the methods we're going to talk about in this video will work. I'm tempted to say 100% chance, but I'm just going to say 99.9%. So if you have an expression in front of you that you're trying to factor, it might have 2 terms, 3 terms, 4 terms, 5 terms, whatever. It's not going to have 1 term, right? Because there's nothing to factor there. The first thing you do, the first step, is you look to see if there's a greatest common factor before any of the strategies we're going to talk about in the video. If you have a binomial or trinomial, you're using grouping, trying to find a perfect square trinomial. Before any of that, no matter what, for any problem, the first thing you do is you factor out the greatest common factor. So like here, first thing you do is say, well, I can factor out a 5, and I can factor out an x. That's the greatest common factor. So you say 5x, this results in 2x squared plus 21xy minus 11y squared. Then you come here to this 3-term expression, and since there's no greatest common factor here, you move on to the next step. The next step, how many terms do you have? Do you have 2 terms, 3 terms, or 4 or more terms? 4 or more. That's the next thing you do, is count the number of terms you have. We're going to start with, what if you have 4 or more terms? What do you do? Well, in that case, if you have 4 or more terms, if you're taking a test or you're working a homework problem and you know that you need to factor this expression that has 4 or more terms, then you're going to be able to factor it by grouping. In real life, you probably can't factor it. It's probably fully simplified. But on a test, on a homework, if you know that this needs to be factored, again, because either the question tells you to factor it, or just because you know the nature of the homework problem or the problem you're working on, 4 or more terms, you're going to be able to factor it by grouping. What is grouping? So we've got 4 terms here in this expression. What you're going to do is you're going to either leave this as it is or rearrange it to where you have a group of 2 on one side and a group of 2 on the other side. So 2 groups of 2. And what you're going to group are the most similar terms together. Now, if you pair terms up and factoring by grouping doesn't work, you can restart and rearrange the terms and try again, no problem. So what does it mean if the grouping works? Well, let's group the most similar terms together here. Well, just looking at the variables, so these x's are the same, okay? These y's are the same, okay? But there's also there's 2 a's here. So what about the coefficients? Well, the 2 and the 6 are divisible by each other, and the 5 and the 15 are divisible by each other. So let's group it that way. Let's have 2ax minus 6ay, and then 5x minus 15y. Right? Each of these has an a, and we can factor out a 2 here. Well, these don't have the same variable, so you could try both. I'm going to do it this way, but if this didn't work, you could go back and try another grouping. Because you could argue that, well, like they have it here, the two x's match up, and here the two y's match up, right? Okay, so we've got these two groups of two. Now we're going to take out a greatest common factor here and a greatest common factor here. Okay, so what's the greatest common factor here? It's 2a, and we're left with x minus 3y. Okay, the greatest common factor here is 5, and we're left with x minus 3y. These two are the same. So factoring by grouping worked. If these two weren't the same, we would go back and rearrange it and try again. Since these two are the same, we can factor out an x minus 3y. So we say x minus 3y, and what are we left with? 2a plus 5. Now we factored this. Okay, for most cases, if you have a 4-term expression, you're going to factor with two groups of 2. For a harder problem, if they're trying to really challenge you, for an advanced problem in factoring, they might make it to where you leave one term by itself and group 3 terms together, and then use a 3-term factoring method. That would be more advanced. The majority of the time, I would venture to say vast majority. If you have a 4-term expression, you're going to be grouping it in 2 groups of 2. Just keep in mind, if it's a really hard problem, they might test your skills and see if you'll leave one term by itself and then group 3 terms together. Okay, that was 4 terms, but you could have more than 4 terms. And we'll come back to that later in the video. All right, what if you have an expression that has 3 terms? Well, the first thing you want to look for is, do you have a perfect square trinomial? If you have an expression with 3 terms, the first thing you do is look to see if you have a perfect square trinomial, meaning you can factor it as a plus b squared or a minus b squared. You can memorize these 2 formulas, or you can just, that it could be a plus b squared or a minus b squared, and you could write it out on your paper. So you say a plus b squared is what? Well, a squared plus ab plus ab plus b squared. And a minus b squared is a squared minus ab, so minus 2ab, minus b times minus b is plus b squared. Okay, you want to check for this first. Okay, so here's 2 examples. You look at this expression, 3 terms. You say, is this a perfect square trinomial? How do you check? Well, you take the first term and take its square root. You take the third term and take its square root. You take those two roots and say 2 times the square root of the first times the square root of the third, and see, does it equal the middle term? If it does, you have a perfect square trinomial. So look here. The square root of 4x squared is 2x. The square root of 49 is 7. What is 2 times 2x times 7? That's 28x. Now this is a minus, but it doesn't matter. Since this is a minus, you're going to say that this is, and you say 2x minus 7 squared. Since this is minus, you put a minus here. If this was plus, you put a plus here. Okay? Come here. This is 3 terms. The first thing you do is check, is this a perfect square trinomial? What is the square root of this? 9c squared. What is the square root of this? 5d. 2 times 5 is 10. 10 times 9 is 90. 90c squared d. That matches this. It's a plus here, so you put 9c squared plus 5d squared. Since this is a plus, you put a plus here. Okay? Okay, here's another 3-term expression. Let's check. Is it a perfect square trinomial? That's the first step. X squared, x. Square root of 12, so 4 times 3 is 12, so you can take out a 2 root 3. The square root of 12 is 2 root 3. So 2 times x times 2 root 3 is 4x root 3. That's not equal to minus 8x. So no, this is not a perfect square trinomial. What do? We go to the factoring by trial and error method. This is what you're probably most familiar with. In particular, you're familiar with the situation where you have a three-term expression with a leading coefficient of 1. And so how do you factor this? You take the third term, so 12, and you separate it into factors. 4 times 3, 2 times 2 times 3. So we have a 6 and a 2. 6 plus 2 is 8. So we have a 6 and an 8. Or a 6 and a 2. So 6, 2. We need to get a minus 8. So minus 6 minus 2 is minus 8. But then minus 6, what is minus 6 times minus 2? That's positive 12. So there we go. This works. So we say x minus 6 minus 2. Now it's factored, right? Because x squared minus 2x minus 6x is minus 8x. Minus 6 times minus 2 is positive 12. Okay? Here's a three-term expression. Well, first this is not in the correct order. You want to put it in the correct order. So put 10y squared plus 27y plus 5. Okay, now check for perfect square trinomial. The square root of 10y squared is going to be root 10y, and then it's not going to be a perfect square trinomial. So what do? Multiply the leading coefficient by the third coefficient. 10 times 5 is 50. Now do the same process as we did for the leading coefficient 1 case. 10 times 5, 5 times 2 times 5. So we have 25 times 2. 25 times 2. We could just leave it positive. Positive 25 plus 2 is 27, and 25 times 2 is 50. But for this case, for the leading coefficient not equal to 1 case, a three-term expression, you're using the trial and error method, the leading coefficient is not 1. Once you find your two terms here, now you're going to factor this by grouping. So you're going to say 10y squared, and then you're going to say plus 25y plus 2y. You're going to separate this, but you're going to group the most common terms together. So we could put the 2y here or the 25y here. Both are divisible by 10, but we have a 5 on the other side. 2 is not divisible by 5. 25 is. So let's do this. Plus 2y plus 25y plus 5. You see how we haven't changed this expression? Now, do the grouping method. Factor out a 2y here, so you get 5y plus 1. Then factor out a 5 here, you get 5y plus 1. Now factor out a 5y plus 1. And that's factored. All right, what if you have two terms? What do? Well, in this case, there's no trial and error method. You're just going, if you have two terms, then you're going to be looking towards one of three equations. Out of this a squared minus b squared, the difference of squares, a squared minus b squared is a plus b times a minus b, or the sum or difference of cubes. And you're going to have to just memorize this formula unless they give it to you, or you can look it up. The sum of cubes, a cubed plus b cubed, is factored like this. A cubed minus b cubed is factored like this. And it wants to note here that a squared plus b squared, you can't do anything with that. Okay? So remember, if you have two terms, you're going to be using one of these equations to factor it. Okay, so what you do is here we have two terms. You see this squared here. So if you come here, there's only one of these equations for two terms that involve squares. So you know this is going to be most likely, unless it can't be factored, is going to be a difference of squares. So you have p squared, and you can write the other term as something squared. So you just, okay, p plus 10, p minus 10. Okay? Here, well, we didn't do this, but what's the first step? Coming back to p squared minus 100. Factor out the greatest common factor. There is no greatest common factor. Then you count the number of terms. There's 2 terms. Then you figure out which equation. Okay? Coming here, factor out the greatest common factor. We can factor out a 2 here. Okay, now let's focus on this. This is 2 terms. We factor out the greatest common factor. Are we going to use the difference or sum of cubes? Probably not, because we know 9 squared is 81. We see a 16. That's 4 squared. This is an even. This is 4, so there's no like cube root of 4. So let's write this as a difference of 2 cubes, or difference of 2 squares. So we've got 4y squared minus 9 squared. Okay, so, all right, so 4y squared minus 9, 4y squared plus 9, right? This is the a, it's a squared minus b squared. This is the a, this is the b. Now, we're not done, and this is another thing you're going to need to be aware of. Sometimes the problem's going to involve multiple steps. So you use one method, you factor it, and then one of your factors, you can factor that further. And that the one that that factor that you're factoring further, you're going to have to start from scratch. Here we've got the difference of 2 squares again, but that's just a coincidence that we did the difference of 2 squares twice. This could end up being the sum of 2 cubes. Okay? So we've got the difference of 2 squares here. So this is 2, and then we have 2y squared minus 3 squared. Okay? Multiplied by 4y squared plus 9. Now this is the sum of 2 squares, but remember, there is nothing we can do with the sum of 2 squares. And so we're left with 2, and then we say 2y plus 3, 2y minus 3, and then 4y squared plus 9. Right? You're multiplying all this together. Okay? So starting from scratch, you say, is there a greatest common factor? No. How many terms? 2 terms. So we're going to be using one of these formulas. Well, you see this cubed here, so you think it's going to be the difference or sum of cubes. Well, this is going to be the sum of cubes. So this has got to be something cubed. This is 5 cubed. So we've got x cubed plus 5 cubed, the sum of 2 cubes. There's your formula. For this case, a is x and b is 5. So x plus 5, x squared minus 5x plus 25. Now that's factored. Here, step 1, greatest common factor. Well, we can factor out an m cubed for sure, and that's it. Because 8 and 27, that's you can't factor anything out from 8 and 27. So m cubed, then you have 8m cubed minus 27. Okay? Here, start from scratch. We can't factor anything out because we just did that. 2 terms. Well, we see the cubed here, so we think sum or difference of cubes, and we think difference of cubes here. So that we probably, if we're taking a test or working on homework in algebra, I bet there's a strong chance you can write these as two cubes. And you can. So m cubed, this is 2m cubed, and this is 27 is 3 cubed. All right, so you've got m cubed. This is the difference of 2 cubes, where a is 2m and b is 3. So you have 2m minus 3, and then you have 4m squared, that's a squared, plus ab, so 2m times 3 is 6m, plus b squared is 9, and that's factored. Okay, now what are some potential situations where you'll have a more difficult problem? We talked about you could have more than 4 terms. So what you're going to do is, for more than 4 terms, you still use grouping. But like, okay, for this 5-term situation, if you're given a problem like this, you're going to want to group it to where you'll have 2 terms, 2 similar terms together, and then 3 other terms together. And then you're going to factor those separately. And then the idea is you're going to end up with common factors based on factoring those separately, and then you'll factor from there. Now, for a really hard problem, maybe they want you to leave 1 term alone and have 4 terms and then factor a 4-term expression. I doubt that. But just saying, you can group it kind of any way you want. Group 4 terms in 1 term, but I doubt you'd ever have a problem like that. So what we're going to do is we're going to leave this as it is. So have this x minus 1 by itself and this by itself. So, okay, let's factor this 3-term expression. First step, greatest common factor. We have an x squared we can take out. So x squared plus 2x plus 1. Okay, and now this is factored. We can't do anything with this. It's kind of like, you can look at it like that, x plus 1. All right, so now we need to factor this. There's no greatest common factor, 3 terms. Is it a perfect square trinomial? Well, okay, x squared, square root of that is x, the square root of 1 is 1. 2 times x times 1 is 2x. Yes, this is a perfect square trinomial. So we can write this as x squared, and then we had x and 1. Okay? And look, this is what grouping does. Whenever if you're gonna end up factoring both of the groups, and you're gonna get a common factor. So we can factor out an x plus 1. So we take an x plus 1, and we're left with x squared times x plus 1 plus 1. Right? So you've got x plus 1, and then you can say x cubed plus x squared plus 1. Okay, now here's an example of something that would probably be a more advanced factoring problem. You get, and this is much rarer. So you've got 4 terms here. You factor out the greatest common factor. There's no greatest common factor. You've got 4 terms. So you're going to use grouping. The vast majority of the time, if you've got 4 terms, you're going to group them 2 pairs of 2. And I mean, that's the first thing I would think here. You see this 25 minus x squared. Well, that's 5 minus x, 5 plus x, and then here we factor out a minus 4y. I would be thinking this is definitely going to work. So you have x plus y. Well, this didn't work. There's no x plus y over here. So this is not, the grouping didn't work here. Okay, so you could rearrange them. So maybe you put the x squared with this 4y squared and the 25 with the minus 4xy. Try it. That's not going to work. So then you could say, well, let's leave this 25 by itself and group these terms together. So let's take out a minus 1 to make everything positive. So x squared plus 4xy plus 4y squared. Okay, so now let's factor this. Greatest common factor? No. Well, there is none. 3 terms. Okay. First step. Is this a perfect square trinomial? Okay, square root of x squared is x. Square root of 4y squared is 2y. 2 times 2y times x is 4xy. Yes, this is a perfect square trinomial. So with x and 2y, so x plus 2y squared. Right, this is a plus. 25 minus x plus 2y squared. Now, for certain problems, remember, it's multi-step. So are we done here? Well, this brings me to the next point, the next level of difficulty. For advanced factoring problems, you're going to need to look for the potential for substitution. Like you need to look for patterns. So this is like a 2-term expression. It seems like this is more than 1 term, but you can look at this as 1 term minus another term. Okay, if we have 2 terms, what do we look for? one of these equations. Well, okay, we have a squared here. So do we have a difference of two squares? Well, we've got 5 squared, and then we've got minus this squared. So we do have a difference of two squares. It's just harder to see because this is all one term here, this x plus 2y. Okay? So we've got the difference of two squares where the a is 5 and the b is x plus 2y. So a plus b, a plus x plus 2y, and then a minus x plus 2. So okay, this is really tricky here. We have our, okay, this is the difference of two squares. The a is equal to 5, the b is equal to x plus 2y, right? If you come here, a squared minus b squared, a plus b, a minus b. Okay, we did the a plus the b. Now we're going to do the a minus all of b. You see? So what we have is 5 plus x plus 2y and 5 minus x minus 2y. Now it's factored. So here's another example where you need to look for that pattern. This is advanced level difficulty. Do we expand all of this out? We could expand all this out and see if we could factor it. But you got to be clever and see that we've got something squared plus 2 times something minus 24. What if I said that u is equal to x squared minus 5? What would happen? I would get u squared plus 2u minus 24. Well, I know how to work with this. Let's factor this. Is there a greatest common factor? No. How many terms? 3 terms. Is this a perfect squared trinomial? Well, square root of u squared is u. Square root of 24 is, so 2 root 6. So this is not a perfect square trinomial. And then you can't even, this is a good example of, you can't take the square root of something and get a negative number anyway, right? So if you look at the perfect square trinomial formula, it's always plus b squared, right? So this is not a perfect square trinomial. We use the trial and error method. So we've got 24, 12 times 2, 6 times 2 times 2, 3 times 2 times 2 times 2. Okay, 6 and 4. Yeah, so we can do, so we have 6 and 4 is 24. We can say plus 6 minus 4. Okay, yeah, so we've got u plus 6, u minus 4. Okay, now substitute the u back in. You got x squared minus 5 plus 6, x squared minus 5 minus 4. Okay, so x squared plus 1, all right, and then x squared minus 9. And now here's another example. This is a multi-step problem. X squared plus 1. That we can write that as the sum of x squared and 1 squared, but there's nothing we can do with the sum of squares. Here we have x squared minus 9. That's x squared minus 3 squared. We can factor the difference of two squares. Okay, so we have x squared plus 1, x plus 3, x minus 3. Now we're done. Okay, now here's the last advanced level difficulty situation you could come across. You might have negative exponents or fractional exponents. So what do you do here? If you come across a problem like this, you're going to want to, well, think about making a substitution, but also you might be able to factor out, like do a clever factoring to where, okay, if you say if we factor out an x to the minus sixth, what are we left with? 2 plus 5x plus 7x squared, right? Multiply, distribute this, and you'll get this back. So we can rearrange this. We've got 7x squared plus 5x plus 2. Now just proceed as normal with this. Okay? Same idea here. Let's try factoring out an x, a 2x plus 5 to the minus 1/2. You get x plus 2x plus 5 to the first, right? Distribute this and you'll get this back. So we can say 2x plus 5 to the minus 1/2, and then this is 3x plus 5. Now we can bring this into the denominator, this 2x plus 5 to the minus 1/2, and we get 3x plus 5 right? That's factor, that's simplified.